For our last video of the section, we are going to look at doing multiple transformations on a graph. We're going to do that in two ways. First, we're going to take a function given by a formula, and given some transformations, find a new formula that puts those transformations into effect. Then we're going to take a function given by a graph, and given a new function given by some transformations, look at what the final graph is going to look like. All right, so the first function we're going to look at is f of x equals 2x squared plus square root of x. And what we're going to do is the following transformations. We're going to compress the function vertically by a factor of 5. We're going to move the graph to the left 2 and up 3. And then we're going to reflect the resulting graph over the x-axis. All right, one step at a time. First thing we're going to do is do our compression. Now, compressed by a factor of 5, compression means that our multiple is going to be between 0 and 1. And so instead of multiplying by 5, which would stretch the function, we are going to multiply by 1/5, which will compress it by a multiple of 5. For our vertical translation, all we're going to do is we're moving up 3. So all we're going to do is take our y-coordinate and add 3 to it. For our horizontal translation, we're going to move to the left, which means everywhere we see an x, we're going to replace that by x plus 2. So instead of x squared, we get x plus 2 squared, and instead of square root of x, we get square root of x plus 2. And then finally, for the reflection, all we're doing is changing the sign of our y-coordinate. So we're just taking our entire y-coordinate and sticking a negative sign in front of it. And that's our final formula. All right, so here's another problem, our last problem, where we're going to be looking at a graph, and we don't have an explicit formula for f of x. It's just going to be y equals f of x, but I'm going to graph a new function that goes by the same f, right? But the formula is going to be negative 2 f of x plus 4 plus 1. So again, we don't have a formula for either of those explicitly, but we can tell by looking at it how to do transformations to the graph to make the graph look appropriate. All right, so let's give it a go. So we're going to take it, the idea is to take it one step at a time. We're going to start with y equals f of x, do one transformation at a time until we have the right formula. Now, the first thing you might notice is that in front of the f part, I mean, it's f of x plus 4, but we have a 2 in front of it, which suggests that maybe we should do a vertical stretch. Right, so we're going to go ahead and do a vertical stretch by a factor of 2, y equals 2 times f of x. It's not exactly what we want for the function, for our new function, but it's getting us closer. So when we do that, we're going to stretch it by a factor of 2, and it's going to look like this. The next thing we'll do is notice that it's not a 2 in front of that f of x plus 4, but a negative 2. So that means we're going to want to do a reflection over the x-axis. So we're going to take our old y-coordinate, 2f of x, and just switch the sign, negative 2f of x. And when we do that, that's going to flip the graph over the x-axis. And we're getting closer. Now, the next thing you see is that plus 1 in the formula. And plus 1, adding a plus 1 to the y-coordinate means you're going to raise it by 1. So if we then do a vertical translation, that's going to take that negative 2 f of x, add 1 to the y-coordinate, and that's going to move the graph up by 1. And then we're almost there, right? Because we have everything is the same, except instead of x plus 4, which we want, we just have plain old x in the f. So we have f of x plus, we want f of x plus 4, but all that is doing is taking our x, replacing it with x plus 4, and that is simply a horizontal translation. So we're going to have negative 2 f of x plus 4 plus 1, and that is a horizontal translation to the left. So we're going to move it 4 units to the left, and there it goes. All right, so go ahead and try these techniques on the activities. It's called combining transformations of graphs.